Please welcome to the stage Dr. Timothy Reissman.
Engineering is a profession that creates value through innovation. And as educators in engineering, it is important that we develop within our students their ability to innovate. This means that we need to do more than teach them technical skills. We must also develop within them an entrepreneurial mindset. Keene describes this mindset with the 3 C's: curiosity, connections, and creating value. See, with strong technical skills and these 3 C's, our students will develop their ability to innovate. So how do we develop the 3 C's? At the University of Dayton, we looked for inspiration. And what we found was something that nearly every one of us are familiar with: Legos. Yes, Lego the toy company. The one that, as of 2015, is the largest toy company in the world, with revenue at over $5 billion a year. Their strategy? Develop a product that is fun, one that intentionally builds our curiosity, and one that gets us to continually connect. See, Lego has created enormous value out of harnessing our desire to explore. So, we use Lego as our inspiration and embrace their strategy to develop the 3 C's. Want to know the results? It worked. We harnessed that incredible value of fun exploration, just like Lego has done since 1932. We witnessed our students doing more than what we asked of them. We witnessed them innovating. We witnessed them developing an entrepreneurial mindset. So, to better understand how to develop the 3 C's in your curriculum, I'm going to elaborate on 2 building blocks from our strategy so that you can build your own. After all, building is the Lego way. Okay. Building block 1. Use something like Legos and start early. In the second year of our mechanical engineering curriculum, we had our classic Intro to Circuits course. It was one of those breadth courses that our students took even though they weren't electrical engineers. But because it was often viewed as disconnected from their major, students often dreaded the course. And their performance, well, let's just say it wasn't all that high. Seeing an opportunity to improve our curriculum, we revamped it to become a mechatronics course, one that would connect to their major and develop the 3 C's. So, using a Lego strategy, we started by creating maker kits. Inside of those kits were basic electronic components for building circuits, a microprocessor board known as an Arduino, a suite of sensors and actuators, and a mini lab device with a power supply, function generator, and oscilloscope. Students purchased these kits for the same price as that old course's textbook. And the course? Right from the start, students were told that by the end of the semester, they would be competing in a class-wide robotics competition. Those kits, they had all the components necessary to build their robots. Something we thought Lego might do. So, with the promise of a friendly competition, their curiosity was sparked. Guiding their development, exercises were hands-on and robotics-themed. No longer relegated to the lab, experiments were done in the classroom. The result? Connections were now being made in real time. And by the end of the semester, students celebrated by participating in their own form of March Madness. The latest? A sumo bot tournament with autonomous robots. Like sumo wrestlers, each autonomous robot had 2 objectives. 1, stay in the arena. And 2, push your opponent out of the arena. The students were really into it, and their robots, they did more than those 2 objectives. As students created value in trying to find competitive advantages in the hopes of becoming that semester's champion. So now, instead of having a course with low performance, we're having students push themselves to do more than what we expect of them. And, like Legos, they're having fun in the process. So building block 1, use something like Legos and start early. At Dayton, we created maker kits for our students to use in their second-year mechatronics course. Now think back to your courses. Is there a course early on in your curriculum that you would like to revamp? And if so, what form of Legos could you use to spark their creativity? For it was through creating maker kits that our students became curious, began to connect, and to create value. Okay. Building block 2. Make sure the Legos you choose are reconfigurable and use them in a subsequent course. See, by choosing to use maker kits, we strategized that, like Legos, they could be easily reconfigured. The subsequent course we chose, experimentation, as it occurred in our students' 3rd year. Perfect. See, experimentation inherently uses instrumentation. And by reconfiguring our kits, by adding some sensors to them, they could become the instrumentation used to build the 3 Cs. So, like mechatronics, our new experimentation course was no longer tied to the lab, but allowed students to think outside of that lab box. And no longer tied to just the robotics theme, these reconfigured kits allowed students to become curious about topics of their own choosing. Want some examples? How about adding force sensors to study the biomechanics of jumping? How about adding temperature and humidity sensors to study the efficiencies of HVACs in buildings? Want something a little more fun? How about adding accelerometers to test the aerodynamics of rockets? You name the topic, our kits likely had a way to be reconfigured. And now, in the students' 3rd year, the faculty weren't the ones creating these new kits. Instead, building on the 3 Cs, students were the ones reconfiguring them. By having the students connect what was needed methods-wise, they understood more about what they were testing. And by the end of the semester, they learned the value of creating instrumentation. So now, at the end of the semester, our students are designing experiments entirely on their own, and they're invested in discovering the results. So back to building block 2. Make sure the Legos you choose can be reconfigurable and use them in a subsequent course. At Dayton, our students added sensors to reconfigure their kits within their 3rd year experimentation course. Now think back to building block 1 and that course you'd like to revamp. Could a subsequent course use your Legos to build the 3 Cs? Now back to those 3 Cs. Curiosity, connections, and creating value. At the University of Dayton, we embraced a Lego strategy. In building block 1, we created maker kits to engage the 3 Cs. In building block 2, we built upon those 3 Cs, reconfiguring our kits to be used in a subsequent course. And now, we are building a strategy to develop our students to think like entrepreneurs, to innovate. So, if you're looking for inspiration to do the same, we encourage you to find some Legos. There are over 400 billion pieces out there, and let your mind explore. Thank you.